This is part 5 of renovating a Mary beam engine. As you can see here, I'm using a pair of pliers to check whether there's any play in the crank pin, and indeed the crank pin is loose. These pliers do not have a serrated edge to the gripping surface. That would mark the work. The gripping surface is perfectly smooth, and I'm also using the pliers here for knocking out the cotter pin. Here is a diagram of how a steam engine cotter pin system works. It's a great system, very simple, and it holds the brasses in place. But unfortunately, on model sizes, the cotter pins generally fall out. If you look on the diagram, you will see that it shows a set screw, which holds the larger of the two cotters in place. That's fine on the full size, but it's not too good on a very tiny steam engine. The bolt would either have to be unfeasibly small or very large and overscale. With the connecting rod moved out of the way, spinning the flywheel shows there is no real problem. Nothing is clunking, it's running very smoothly. As you can see on screen at the moment, there's some side play on the crankshaft, and also the top cap of the inner bearing is a bit loose. This of course won't help with the knocking problem, but I don't think in this case it's side play on the crankshaft that's the problem, and I can confirm this by putting my finger on the end of the crankshaft to take up the side play, and it makes no difference. This is the Watts parallel motion end of the beam, and as you can see it's very loose, and it's very loose because one of the cotter pins is missing altogether. The larger of the two cotters has completely disappeared, and this allows everything to flop about at one side. This is where the knocking effect is coming from. So it's time to make a new taper cotter to replace the one that's missing. It's a simple sawing and filing job, and when it's fitted we'll see what happens. So as you can hear now, the engine sounds much better, much healthier all round. If you are using an engine with taper cotters, never put the taper cotters in with any Loctite products like 601 or 603 bearing retainer. It's okay to use a little bit of thread lock, but that's all. If you do use the high strength bearing retainer, you will not be able to successfully adjust the cotter pins without applying heat. Whilst watching this engine turn over, I noticed that there is the slightest, and I mean the very slightest, amount of error in the valve setting. It's very easy to go into obsess mode when doing this and getting it just right. I will only do this if the engine is very well made. I don't like doing it when I'm compensating for bad manufacture, but in this case the engine's very well made and it's just the icing on the cake. But what I'm going to do first is purposely do it wrong, so you can hear how bad the engine sounds when the timing is out. This is with late timing, so all the metal parts go to the full extent of their travel before the steam is admitted. By moving the position of the eccentric relative to where the crank pin is on the crankshaft, the valve timing can be changed. A word of warning, I'm carrying out this procedure with a very small amount of compressed air being applied to the engine. By doing it this way, I can tell at which point of the revolution the engine is admitting the steam. But I'm only using about 4 to 5 psi. Any more than that and this would be a very dangerous operation. There's still a slight way to go on this to make it how I want it, but I'll do that when the camera's not on because it takes quite a long time. I'm using a Mammoth style drive belt which will drive the governor. When cutting these belts, make sure you cut the open end, not the fancy shaped end. Here's the belt fitted to the governor drive. I've got the tension right because it's going round okay. The only problem now is when it's going fast the governor actually hits the columns, but that won't happen once I've made the governor linkages connecting the governor to the governor valve. The big end cotter pin is still slightly slack, so I tap it very gently with the hammer, and now we go to warp speed. You can both see and hear what's happening when I let go of the governor lever. The good news is none of the cotters fell out and everything's running rather well. Thanks for watching, I hope you found it useful.